This is our second video on the conic form of a parabola equation. And so before we get started graphing a couple more of these, we're going to put the standard form of the equation up here so that we can have it to look at. Now, one form is y minus k equals x minus h squared. And remember that 4p always goes with the unsquared term. So the 4p is next to the y minus k. And then the other form is x minus h equals y minus k squared, and the 4p is sitting next to the x minus h. So this would be the equation, the standard form for the parabola equations that open to the right and to the left, and the top one would be for the parabolas that open up or down. All right, so let's look at this equation. 8 times y minus 2 equals x squared. Now, first of all, I see that y is my unsquared term, x is my squared term. So this is going to be a parabola that opens up or down. And when I look at the 8, I notice that it's positive, so this one's going to open up. When I look at that equation, the hk in these equations represents the vertex. All right, so hk is my vertex. Notice that I don't appear to have an h with my x, but that just means h is 0. So my vertex for this equation is 0, 2. There's my vertex. I know it opens up. So I can go ahead and do a quick sketch of this parabola. You see, here's my vertex at 0, 2, and I know that my parabola opens up. Now, let's find our focus and our directrix. To find the focus and directrix for this parabola, I have to know p. Well, p is right here in this 8, because remember that 8 is equal to 4p. So when I solve this equation, then I get p is equal to 2. This means that the focus is 2 units away from the vertex on the inside of the parabola. That would put it right here. So here's my focus. So my focus is at the point 0, 4. Remember, your focus is a point. And my directrix is the line, the horizontal line on the outside that is 2 units away from the vertex. And so in this case, my directrix is actually going to be my x-axis. And the equation for the x-axis is y equals 0. So here's my focus, my directrix, and my vertex. We got all of that from that equation. All right, let's do another one. Now this one I'm going to have to work with a little bit to put in a proper form. All right, this is y squared minus 6y minus 3x plus 6 equals 0. All right, now in order to put this into one of our standard forms, we're going to have to separate the variables with the squared term from the variables that do not have a squared term. So I'm going to separate this 3x and the constant, the 6. I'm going to move those to the other side so that I can complete the square with the y variables. So I'll have y squared minus 6y equals 3x minus 6. I just moved the 3x and the 6 to the other side to get them out of the way. Now I need to complete the square on this side, which means I'm going to be adding a term to that side. So I'm going to have to add a term to the right-hand side. All right, remember it's half the middle term squared. So half of 6 is 3 squared. 3 squared is 9. All right, so now I have a perfect square trinomial, and I'm going to write that perfect square trinomial in factored form. So it's going to look like y minus 3 squared. And then over here I'm just going to combine my numbers, so I've got 3x plus 3. Now I almost have it in our standard form. All I have to do is factor this 3 out. So I have y minus 3 squared equals 3 times x plus 1. All right, so now I have a standard form equation for my parabola, and in this you can see that the vertex is -1, positive 3. -1, 3. All right, so let's sketch this. -1, 3 would be right here. Now, when I look at my equation, I see that the y is squared, which means that we're going to have a parabola that opens to the right or to the left. Since my 4p, which is 3, since it's positive, I know that my parabola is going to open to the right. So here's my vertex, and it just opens to the right. All right, now let's find my focus and my directrix. All right, so I use my 3, because 3 is equal to 4p, and I need to know p to know the focus and the directrix. This means that p is equal to 3/4. So to find my focus, I'm going to move 3/4 of a unit inside the parabola, and that would put it right at -1/4, 0, -1/4, 3. So this is my focus. And then my directrix is going to move 3/4 of a unit to the outside of the parabola. Remember that it's going to be this line on the outside. And it's a vertical line this time, so the equation for the directrix is x equals, and I can say x equals -1 3/4, or I can say x equals -7/4. You know, whichever way you want to write that. But that is the equation for my directrix. All right, well, let's suppose we want to go backward and we want to write an equation for a parabola for which we have some information. All right, so let's suppose that I know my vertex and I know my focus, and I want to write an equation for that parabola. All right, so my vertex is 5. Let's say it's 5, -2, and my focus is 5, 1. In order to write this equation, I need to know first which form to start with. So what I'm going to do is do a quick sketch just to see how is my parabola going to be turned. And I can tell that with the focus and the vertex. So my vertex is 5, -2. 1, 2, 3, 4, 5. 2 units down, so that's going to be right here. And then that's my vertex. My focus is 5, 1. 1, 2, 3, 4, 5, up, 1. So this parabola is turned up. All right? This parabola is turned up. Now, I can tell from looking at the focus and the vertex what P is. P is the distance between the two, and that's 3 units. So P is equal to 3. Well, to write my equation, it's turned up, so that's going to be the top equation, and all I need is P and HK. Well, I have HK, that's my vertex, and using my sketch, I have P, which is 3, so I'm just going to plug those in. 4 times 3 times y minus k, and k is -2, so it's going to be y plus 2, and then equals x minus h, and h is 5, x minus 5 squared. So I just multiply the 4 and the 3, I get 12, y plus 2 equals x minus 5 squared. And this is my equation for this particular parabola. All right, but let's suppose that we have another real-life situation. Let's suppose that we have a parabolic reflector. So it's a reflector shaped like a parabola. Okay, so we have a parabolic reflector, and I know that this parabolic reflector is, let's say that he is 16 units across from end to end. And let's say at its highest point, it's 5 units deep. All right, in order to write an equation for this, because what I want to do is I want to find where the focus is. I want to put something in the position of the focus. This is a reflector, so I want to put something where the focus is. I need to locate the focus. How can I do that? Well, the first thing I want to do is write an equation for it, because if I can write the equation for it, I can find the focus. Okay, well, I'm going to put this on an XY plane. Now, you can put it any number of places on the XY plane. You know, a lot of people would do like this and would put it right here so that this is 5 and this distance is 16, but of course that means this is 8 and this is 8. And you can do that, but I'm not going to do that. Instead, I'm going to put mine so that the vertex is at the origin. Now, another thing that you can do is you don't have to turn it upside down. You could turn it right side up. I'm going to go ahead and turn mine upside down because we haven't done one of those. I'm going to do that just because I can. All right. Now, this is 8 units across, and this is 5 units down. But what this does for me is it puts my vertex at 0, 0. So my vertex is the origin. That means that my equation is going to look like the top equation, but my HK is 0, 0. So I'm going to have 4py equals x squared. All I have to do is find p. Well, it just so happens that I know a point on my parabola that I can put in for x, y, and solve for p. And p then tells me where my focus is. All right, well, what is that point? Well, this point right here. Because you see, this point is 8 units across this way. So that's 8 in the positive x direction. And it's 5 units down. You see, because this is 5. So this point right here is 8, negative 5. If I just put that point in here, I can solve for p. Well, let's do that. So 4p times negative 5 equals 8 squared. Well, that means that negative 20p equals 64, or p equals 64 over negative 20. And I can reduce that. They both are divisible by 4. So I can reduce that to negative 16 fifths. P is negative 16 fifths. That means that my focus is 3 1/5, 3 1/5 units down. 3 1/5 units away from my vertex. Now I found my focus. This is where I want to put whatever it is that I'm going to be using this parabolic reflector for.